So a lot of times you're asked to sketch the derivative of a function given another graph, or at least like read which one's the derivative of what. And so this is just some tips. Like these are all things that we already know, but they're just some tips that I would say when you're doing a question like that. So always look at the slope of f of x and put that as a y value for the f prime of graph. And the easiest one to look at are for the slopes are easier to see when the slope is 0. Okay, so I'm only looking at the signs of the slopes or the when they're 0, right? That's primarily what I'm looking for when I'm sketching it. So for example, if I given a function like this and I want you to sketch the derivative, what I might do is I say like, well, I have horizontal derivatives here, horizontal tangent lines here. So those are zeros. I would go down here, it's going to be 0, it's going to be 0. Here it's going to be about 0. So that means the y value of the derivative is going to be 0 at those points because the slopes are 0. Then I'm just looking, okay, I got positive slopes and I have negative slopes. So it's got to kind of, like, it's got to go from here to here being positive slope and then, like, negative slope. Now, I'm not getting the exact value there, but it's going to do something like that. And then it's going to be negative slope. So that means the y values are negative. So I'm looking for positive y values here and then negative y values because these are positive slopes and then negative slopes. So the y values after this point become negative. The y values before that point become positive because the slopes here are matched to the y values on the f prime of x graph, right? So then here we still have positive slopes. So rather than go straight through here, it's going to like kind of bounce here, right? Because the slopes stay positive. It's like they're positive slopes, then 0, then positive slopes. So the y values of the derivative need to be positive, then 0, then positive. So it's going to come back up, still positive slope, and then right around there. Oops, sorry, I don't know why I did that. It's got to go up, and then it's got to come back down, go through there. And then now the slopes are negative over here, so the y values need to be negative. So if I erase all my kind of hairy sketches on the tangent lines, you can see the red curve ends up being the graph of the derivative there, right? Like that. Let's take a look at this one here. So again, we want to look for horizontal tangent lines and stuff like that. So around here, this one is a discontinuity on the slopes here. So to the left here, look at the slope. This slope is like, I don't know, negative. It's constant and it's negative. We'll just say like negative 3-ish or so. It would be like this. And then it's going to have an open circle here because right at this point it's not differentiable. So it means the y value for the derivative shouldn't exist, right? Because this is a sharp corner, so it doesn't exist. But on the right side, the slope is approaching, looks like 0. So we put a 0 here, and then the slopes look like they go positive and positive. Because right around there, from the right side, the slope looks like 0, and then it's going to go positive. So it's probably going to be, and this looks kind of quadratic-y, so I'm just going to have it go straight up like that, right? Just the slopes get steeper, so it just needs to go up. The exact shape would be very difficult to see from a graph. Okay. I want to give another scenario that you might be given is like sometimes you're given 3 graphs and you want to know which one is f, which one's f prime, which one's f double prime. How do you go about doing that? Well, I do the same thing. I look for, let's start with curve A. Curve A has a horizontal tangent line here, and that's the only one here. So it should have a 0 at that point. And then it has negative slopes. So it looks like, what I'm telling here is B definitely looks like the derivative of A. Right? And so we want to look at the rest of it. We have negative slopes. The y value is negative, so that matches. Then we have only positive slopes here, and we have positive y values here. So it looks like B is the derivative of A, the A dx, or you can write it as A prime if you want. Right? So that's something we know. Now let's look at curve B. Let's look at his slopes. When are they 0? Well, there's a 0 right here. And then it looks like there's one right about there, horizontal tangent line. So here we should have a 0, and about here we should have a 0 as well. And it should stay kind of 0-ish. So it looks like C is the derivative of B. Okay, so then you say like, well, let's just check the slopes. These are negative slopes. So we need to, in this region here, we need to have negative y values, which we do. So that's good. And then we look at positive slopes here, right? So we should have positive y values in this region, which we do because it's above the y-axis, right? So it's looking pretty good. So I'm going to write that as C equals the derivative of B. Let's look at C. Let's verify the last one, though, because we didn't actually check C. So if we go in a circle, this will be kind of a problem. So C has a 0 here, horizontal tangent line here, and looks pretty horizontal right around there. So around there, should have a 0. Around here, should have a 0. Around here, should have some zeros. Okay, so none of them match, right? Because no one has a 0 right at this point. So there's no derivative of C on this graph anywhere, which is good because we've kind of eliminated them. So therefore, B is the derivative of A and C is the derivative of B. So A is f of x. Then B is f prime of x, the derivative of A. And then C is the derivative of B. And so that's what we're doing. We're just looking for when we got those horizontal tangent lines. That means the derivative is 0. The y value of the derivative ought to be 0 at that point. And then we're also looking for when the slopes are positive. That means the derivative needs positive y values. And when we have negative slopes, right, then that means the derivative has to have negative y values.